Hello and welcome to my channel We Learn by Sharun. I am Shraddha Banode, Assistant Professor in St. Vincent Pallotti College of Engineering and Technology, Nagpur. In this series, we are learning electrical machines 2, which concentrates on synchronous machines. And in today's class and in today's session, we are going to see the transient behavior of alternator under fault or short circuit condition. So transient behavior, let's go step by step. First of all, I'll tell you what are the conditions when we study transient behavior, and then I'll tell you what are the parameters you see when you go for transient behavior. Okay. So before understanding the transient behavior of the alternator, let's try to understand the state, the various state concept of, let's say, subtransient, transient and steady state. तो जब तक कोई ट्रांजिएंट बिहेवियर नहीं आता, जब तक कोई शॉर्ट सर्किट नहीं आता, जब तक कोई फॉल्ट नहीं आता, तब तक का जो स्टेट होता है वो होता है स्टेडी स्टेट. ठीक है. स्टेडी स्टेट इज द नॉर्मल वर्किंग कंडीशन ऑफ एनी मशीन. ऑल राइट. ठीक है. Now we are going to study, basically we are going to concentrate on subtransient and transient state. Okay. Now the subtransient, transient and steady state arises in case of fault in an alternator. जैसे मैंने आपको बताया कोई भी unbalanced condition हो या faulty condition हो, short circuit condition हो, then we have to take care of this transient behavior. And what are the state we need to learn carefully is the subtransient state, transient state and the steady state. Now let us assume a sudden short circuit in the three phase of the alternator. Basically fault, short circuit, it is all one and the same thing. तो कोई sudden short circuit हो जाता है या कोई failure हो जाता है एक three phase alternator में, how things go. Obviously whenever there is a short circuit or there is a fault, there will be flow of short circuit current or the faulty current. Okay. So the fault current or the short circuit current that flow in all three phases of the alternator. So let's try to understand the behavior of this. See, basically we assume that all three currents are in balance condition under normal condition, but when there is fault or certain short circuit condition, then the current behavior changes. Okay. Now, the pattern what you can see on the diagram right now on the screen, there are three phases that has been told, that is phase R, phase Y and phase B. Okay. Now, in this, the current is not going to zero ultimately, but what basically we are going to study is at this position where just the fault is taking place, or we can say just the short circuit has been taken place, then the current will show its subtransient behavior. Now what do you mean by subtransient behavior? अगर एक suppose 5 ampere का current flow हो रहा है under normal condition में, as soon as the fault will be there, the current that will flow will be like 8 to 10 to 15 to 20 times of the rated current. Okay. एंड वो जो एक बहुत ज़्यादा करंट फ्लो होता है, ठीक है, उसका एक स्टेज होता है, पहले वो बहुत ज़्यादा फ्लो होता है, लाइक इट विल बी 15 to 20 टाइम्स ऑफ द रेटेड करंट, और फिर धीरे धीरे जो उसका डिमिनिश होने लगता है, ये जो हायर वैल्यू है ये धीरे धीरे कम होने लगती है. ठीक है. So the second stage that will be the current will be say 8 to 10 times or 3 to 5 times the rated current. That will be another stage, and the third stage will be steady state stage where the current will try to take its original position. Okay. So आप जो यहाँ पे देख रहे हैं, ठीक है, आपको यहाँ पे दो तरीके के कर्व्स दिख रहे हैं. एक आपको साइनसॉइडल वेवफॉर्म दिख रही है. लेट्स कॉन्सेंट्रेट ऑन आर फेज फर्स्ट. ठीक है. और आपको एक डॉटेड लाइन दिख रही है. तो डॉटेड लाइन इज सपोज टू बी द आरएमएस वैल्यू, और ये जो है ये आपका एक साइनसॉइडल वैल्यू है. ठीक है. तो अंडर नॉर्मल कंडीशन में क्या होगा? अंडर नॉर्मल कंडीशन में आपको एक नॉर्मल वेव फॉर्म दिखेगी. लेट मी ट्राई टू शो दिस विद द हेल्प ऑफ दिस पेन हियर. तो एक जो इस तरीके का अगर मैं आपको दिखाऊं स्टेडी स्टेट, तो जो अगर फॉल्ट के पहले जो करंट एक फ्लो हो रहा है वो इस तरीके से फ्लो हो रहा है, एकदम नॉर्मल फ्रीक्वेंसी में जा रहा है, एकदम नॉर्मल मैग्नीट्यूड जा रहा है उसका. ठीक है. लेकिन जैसे ही फॉल्ट होता है तो क्या होता है, करंट बहुत ज्यादा फ्लो हो रहा है, इसलिए आप देख सकते हो. अच्छा, ये अनबैलेंस्ड भी है. आप देखोगे कि अगर ये आर में ऊपर ज्यादा है तो नीचे में कम है. सिमिलरली वाई का एक अलग तरीके का बिहेवियर है, बी का एक अलग तरीके का बिहेवियर है. वो क्यों है? क्योंकि तीनों में एक 120 डिग्री का फेज डिफरेंस है. ठीक है. तीनों में एक 120 डिग्री का फेज डिफरेंस है, इसलिए आपको ये तीनों का जो बिहेवियर है वो भी आपको अलग अलग दिखेगा. ठीक है, तो इंस्टेड ऑफ फ्लोइंग लाइक दिस एज सुन एज द फॉल्ट अकर्स, तो आप देखोगे आर बहुत ज़्यादा हो गया है, इट इज़ ऑलमोस्ट 15 टाइम्स द रेटेड करंट, एंड देन स्लोली अगर आप देखोगे तो उसका जो मैग्नीट्यूड है वो कम हो रहा है। तो ये जो पीरियड होता है, ठीक है, जो फर्स्ट 2 to 3 साइकिल्स होते हैं, दिस फर्स्ट 2 to 3 cycles are nothing but sub-transient period. This first 2 to 3 cycles are called as sub-transient period. All right. So I was explaining that before a short circuit, the current wave used to be normal as I've shown here, okay? And as far as I already explained you that R, Y, and B, all the three phases will react differently because of the phase difference between them. तो जब आप इस तरीके की थ्री फेजेस ड्रॉ करोगे तो आपको ये पता होना चाहिए, सी आर इज गोइंग मोर टूवर्ड्स अपर साइड, वाई इज गोइंग लाइक ऑन अ हॉरिजॉन्टल वे, एंड बी is going more towards the lower side of the x-axis. So that is because of the 120-degree phase difference between all three. So this is how you can react. And now if you concentrate on this first 2 or 3 cycles, so basically the subtransient period lasts for first 2 3 cycles where the current is much more, like they say 15 to 20% of the rated current. So this is what I have drawn, this horizontal line just separating the subtransient period. So this initial period is called as subtransient period, and slowly then oscillations get damped out because of the damper winding connected in the alternator. Okay. And then the later period is called the transient period. So the transient period is much more than the subtransient period, where transient period lasts for 2 to 3 cycles. Subtransient period may last for 8 to 10 cycles. Okay. All right. So as I told you that the transient period lasts for 8 to 10 cycles. So you can say the middle portion is nothing but the transient period. Okay, and the short circuit current further gets damped out and it goes towards the steady state. The later part of this waveform is the steady state period where the normal current flows, and the alternator has the capability, or the any machine has the capability to take out of this faulty condition to the steady state by itself. So the damper winding helps it. We are going to study the damper winding in detail. So basically, this is how the concept of subtransient, transient, and steady state is. I hope this thing is clear to you. The question is compulsorily to be calm. Like if you talk about this the fifth unit, there are this is a very important question which generally gets asked in examination, and you need to draw this waveform as well, and you need to explain this better. Okay, so when the alternator is short circuited, now the current in the three phases, as I told you that it goes like to very high value and it increases very rapidly. Okay, so it can go to as high as 10 to 18 times, as I told you, 10 to 18 times. Some book may refer to 15 to 20 times, or some book may refer like this. This is the range, 10 to 18 times of the full load current during the first quarter cycle. Means during the first quarter cycle means obviously when you have the sinusoidal waveform with normal frequency, so for the first quarter you have the subtransient period. Okay, so the current goes to very high value and it goes very rapidly as soon as the short circuit occurs. Okay. And also it affects the flux which is crossing the air gap. So for the first couple of cycles, the flux which is there in the air gap also gets affected because of this short circuit or this subtransient period. The reactance during this first 2 to 3 cycles where the transient subtransient period exists, okay, and the short circuit current is very high, okay, because obviously there is a very high current, so it will produce its own flux as well, and also the flux is already there in the air gap. So the reactance which is offered during this subtransient period is also very high. Now, the reactance which is offered to the flux in the subtransient period is denoted by X double dash. Okay, subtransient period रहता है तो उसको double dash से denote करते हैं, transient रहता है तो dash से denote करते हैं. Alright, so this reactance is called the subtransient reactance, very important point, and it is denoted by X double dash. Okay, the first few cycles comes under subtransient state, or you say subtransient period. So the first 2 to 3 cycles is the subtransient period, or it is called as subtransient state. The reactance which is offered during subtransient period is X double dash. Okay, and the current which is flowing in this period is also represented as subtransient current, which is represented by I double dash. I'll let you know that in coming slides. Okay, now after a few cycles, the after that subtransient period, you can say the decrement in the current takes place, and the rapid change current, the speed of the current is also decreases, and hence you get the later part of the cycle, that is called as transient state. Okay, now the next state, where the current is not very high, like 10 to 18 times the rated current, but it is, let's say, 5 to 8 times or 5 to 10 times of the rated current, that comes under the transient state. And you can see that the oscillations are getting damped out during this state. Okay, now this is called as transient period, and the reactance which is offered during this period is transient reactance, and it is denoted by X dash. It is denoted by X dash. Mostly the circuit breaker operates in this transient state. Now what is circuit breaker? You must be having some idea about the circuit breaker. I'm not going to go into circuit breaker in detail, because you're going to learn your circuit breaker in electrical power system 1 as well as electrical power system 2. Okay, बट व्हाट माय पॉइंट इज, जब भी कोई फॉल्ट होता है तो रिले उसको डिटेक्ट करता है, इट गिव सिग्नल टू द सर्किट ब्रेकर एंड सर्किट ब्रेकर ऑपरेट्स, तो वो ओपन हो जाता है, ठीक है। लेकिन अगर सपोज सर्किट ब्रेकर को एकदम सब ट्रांजिएंट पीरियड में सर्किट ब्रेकर ऑपरेट नहीं होता है, जितना टाइम लगता है सर्किट ब्रेकर को ऑपरेट करने के लिए, सब ट्रांजिएंट पीरियड खत्म हो जाता है, ट्रांजिएंट पीरियड आ जाता है। तो अगर सर्किट ब्रेकर को ऑपरेट होना है तो वो ट्रांजिएंट पीरियड में ही ऑपरेट होता है। Okay, finally the transient period also dies out, and the current reaches to its final steady state sinusoidal condition, and that state is called as steady state condition, and that state is called as steady state. All right. The reactance which is offered at this state is proper X होता है। और एक और चीज याद रखो कि जब आप ट्रांजिएंट पीरियड पे डील करते हो, तो the only reactance which is offered is D axis reactance, that is XD. We will not deal with XQ at all when you talk about transient behavior, because of the phasor relationship. Only XD is dominating, XQ is not there. Okay, the reactance in this state is called steady state reactance, and it is denoted by XD. Now since the short circuit, यहाँ पे आपको बताया है क्यों XD ही रहता है, because the short circuit current of the alternator lags behind the voltage by 90 degree because of the reactive nature, inductive nature की वजह से, because the current is lagging behind voltage by 90 degree, the reactance involved are direct axis reactance. अगर आप orally recall कर सके, अगर आप phasor diagram recall कर सके जो मैंने आपको बताया है salient pole rotor का, तो आपने देखा होगा कि जो XQ का इफेक्ट होता है वो वर्टिकल होता है, जिसकी वजह से हम उसको EMF में कंसिडर नहीं करते हैं, and that is why XD is considered, the drops because of XD is considered, the drop because of XQ is not considered. ठीक है। Now this is again a very important phasor important waveform you need to understand. मैंने आपको फर्स्ट स्लाइड में जो दिखाया था वो मैंने आपको इंडिविजुअल दिखाया था आर फेज, वाई फेज और बी फेज के लिए। यहाँ पे ये मैंने आपको आर फेज, वाई फेज, बी फेज नहीं बता रही हूँ, मैं आपको सिर्फ एक कॉमन करंट बता रही हूँ, द करंट विच इज फ्लोइंग, और यू कैन से द आरएमएस वैल्यू ऑफ करंट विच इज फ्लोइंग। ठीक है, so same thing has been explained here. Now here this again, this the you can see this first 2 to 3 cycles are categorized as subtransient state, then the later part is transient state, and the later part is steady state. Okay, so you can see the subtransient period lasts for 2 to 3 cycles, the transient period lasts for 5 to 8 or 5 to 10 cycles, and then steady period goes for with the normal current. तो आप देखोगे कि करंट डाई आउट नहीं हो रहा है, फर्स्ट फिगर में आपको शायद वो लगा होगा, तो यहाँ पे आप देखोगे कि जो करंट है इट इज नॉट डाइंग आउट, इट इज नॉट गोइंग टू जीरो पोजिशन, इट इज जस्ट गोइंग टू स्टेडी स्टेट। तो आपको इस तरीके की वेव फॉर्म लाना है, मतलब आप गलती से ऐसा ना कर दो। व्हाट माय पॉइंट इज, अगर आप इसको और डैम्प आउट करके ऐसे करके आप जीरो नहीं कर सकते। अगर आपने एग्जाम में इस तरीके का कुछ बना दिया तो वो गलत हो जाएगा, आप उसको इस तरीके से जीरो नहीं कर सकते, आपको उसको डैम्प आउट नहीं करना है, आपको सिर्फ एक स्टेडी स्टेट में उसको लेके जाना है। I hope this thing is clear to all of you. So you can see the current which is flowing here is the subtransient current I double dash. The current which is flowing here is the transient current I dash, and the current which is flowing here is the steady state current, that is normally I. ठीक है, तो अगर आप उसका एक steady state या RMS वैल्यू देखोगे तो कैन आई से दैट OC इज द सब ट्रांजिएंट करंट. देखिए आप यहाँ पे जो इसका है DC ऑफसेट करंट जो आप बोलते हैं वो यहाँ इस तरह से जा रहा है, तो आई कैन से OC is the subtransient current, OB is the transient current, and OA is the steady state current. So this is what we are going to define here. As clear from the figure, the DC component of the three-phase current are different and hence the waveform of the three-phase are not identical. Okay, now the voltage of the phase Y is maximum at the instant of short circuit. हमने Y phase यहाँ पे consider किया है, and that is why we are getting the maximum to the maximum current at in the short circuit. DC component of the short circuit is 0. Hence the waveform is symmetrical. आपने देखा R जो है वो थोड़ा ऊपर साइड में डोमिनेटिंग था, B जो है वो थोड़ा नीचे साइड में डोमिनेटिंग था, Y phase जो है वो एक symmetrical waveform था, and that is why we have just elaborated that Y waveform here. Okay. Now the current, so as I explained you, OA will be giving you current that is steady state current, OB will be giving you transient current, and OC will be giving you सब ट्रांसिएंट करंट. तो OA OB OC जो था ये एक मैक्सिमम वैल्यू था. एक बार फिर से मैं आपको ये फिगर दिखा देती हूँ. तो ये जो है ये OA ये जो है ये मैक्सिमम वैल्यू है, OB जो है ये भी मैक्सिमम वैल्यू है करंट की, और जो OC है वो भी मैक्सिमम वैल्यू. दैट इज नॉट द RMS वैल्यू, दैट इज द मैक्सिमम वैल्यू. और इसलिए हमने उसको यहाँ पे डिफाइन करने के लिए OA बाई रूट टू, OB बाई रूट टू एंड OC बाई रूट टू लिखा है. अल्टीमेटली अगर हमें रिएक्टेंस के टर्म्स में को लिखना है तो I is equals to EA. EA is the EMF. EA is the EMF induced. Okay. So I is equals to EA upon XD for steady state. I dash is equals to EA upon XD dash for transient state, and I double dash is the EA upon XD double dash, that is for subtransient state, where I is the steady state current RMS value, I dash, I double dash, transient and subtransient current, EA is the induced EMF per phase, XD is the direct axis synchronous reactance, XD dash is the direct axis transient reactance, and XD double dash is the subtransient reactance. I hope this thing is clear to you. I hope the concept of transient, subtransient, and steady state is clear to you. If you have any doubt till this point, just let me know. This is all about the subtransient, transient, and steady state period of alternator. So in today's class, we have seen how the alternator reacts to the certain short circuit or fault condition with the understanding of subtransient, transient, and steady state period. Okay, don't forget to like the video and subscribe to my channel if you have not yet, so that you don't miss any of the upcoming videos, and press the bell button right next to it. Thank you and happy learning.